Welcome to Electric Evolution with Liz Allan. This podcast is about the journey to a more sustainable future in order for us to be able to do our bit to achieve net zero. I'll be discussing a variety of topics with experts in their field in order to educate and increase our knowledge of clean energy, electric vehicles and the electric vehicle infrastructure. So whether you're an individual wanting to make a difference at home, a small business or a corporate, this podcast is just for you. On today's podcast, I have got Graeme Cooper, who is this is going to be an amazing, interesting and just eye-opening podcast session because Graeme is at such an interesting point in his career, aren't you? At the moment, I will say hi. I will say hi.
Thank you for inviting me, Liz. Thank you.
So, 5 years you've been working for National Grid. And you've been decarbonising transport and heat, but you're just about to move to a global engineering company. Now, there are just so many things, Graeme, that you've done. I've looked at your CV, or kind of what looks like, what is your definitely your experience on LinkedIn even. And I was kind of blown away by it. And I did a little bit of trawling through different kind of platforms and YouTubes and podcasts, and I was totally blown away by what I learned. So thank you for joining me in the first place.
That's right. I'm very happy to do so. It's all about demystifying the transition we're on, right?
So you're literally you've been working for National Grid,
yeah, for
5 years.
Yep.
Can you explain to everybody what you've been doing? So you are at the moment you're head of future markets. Yes. At National Grid.
Yes.
Head of future markets at National Grid. I knew I was going to get my teeth in a tangle today. What did that entail?
So firstly, I mean, don't get lost in the title, right? It's what you do, not what the job title says, right? So what does head of future markets mean? But also, what does National Grid do? Because most people who are not in the energy sector just kind of go, well, National Grid does everything electricity, right? Well, no, and let me explain why. So firstly, National Grid in the UK. We own the transmission system. So, the big pylons, the motorways of the energy system.
Yeah.
And we also, local to you and I, is the National Grid ESO, the control room, the secret control room that manages the real-time supply and demand. So if you think about it in road terms, National Grid is the UK's energy system motorways. And the National Grid ESO, the control room, is effectively the road signs and matrix boards, turning the speed up and down. Yeah. So National Grid doesn't make electricity. National Grid doesn't buy electricity. National Grid doesn't sell electricity. We're just the conduit from where it's made to where it's consumed. And then actually in your home, the last mile bit, the local wires in the street outside and on the wood poles, if you live in the countryside, that's your local DNO, distribution network operator. And actually last year, National Grid bought one of those regional DNOs called Western Power Distribution. Okay. So National Grid now owns big transmission system in England and Wales. It also owns the distribution system in Cornwall, the Southwest, South Wales, and a stripe across the Midlands. So it means we can actually see now everything end to end, everything from big wind farm, big nuclear, big interconnect to another country, right the way down to Mrs. Wiggins at number 32 Acacia Avenue. So it gives us a unique view end to end of a whole system, but we don't buy it, make it or sell it. We are literally the conduit from where it's made to where it goes to. And then my role, crikey, it's a difficult one. So traditionally, big utilities just respond to a very mature market. So I'll give you a for instance, right? So the new Hinkley Point C power station, we've had 15 years to worry about the wire to that. So we've not had to rush because it takes a long time to build a nuclear power station. If you think about the world we're moving into, we're 20 years into changing the way we run the country. So we've gone from big centrally powered thermal plant, so coal, gas and nuclear, and we're moving towards a much more diverse, principally renewable or clean generated system. So we're putting wind farms in the sea, we're putting them on the top of hills in Scotland. So the grid has been changing for 20 years. But how we use energy is really fundamentally changing right now. So the reason why my role is head of future markets is by about 2050, the UK will consume probably at least twice the amount of electricity than we do today. To be able to do that, we need about 4 times the amount of clean generation than we have today. And to do that, we need twice the grid capacity. So let's just come back for a minute. What does that really mean and what's driving it? So if you think of that 100% growth in demand, 20% is decarbonising transport. 50 to 60% of that growth in demand is decarbonising heat. And that's because about 86% of the UK is heated with a gas boiler. All right?
Yeah, that's true.
So the future markets role is to say, hang on, we can see growth in wind, we can see growth in new nuclear, we can see growth in solar panels. Where's that power going to? It's got to go downstream into clean heat and clean transport. And the last thing you want is a coal-fired power station powering a clean electric car, right? That's your your social media nightmare. So I've been trying to help navigate that, okay? Because let's think about this. If the transition to decarbonise heat and transport goes swimmingly well, right wires in the right place, no one's going to go, well done, energy utility industry, you did a lovely job. But if that transition doesn't go swimmingly well, who do you think they're going to blame this?
Exactly.
The big utility. So it's for some of this is about self-preservation. It's about making sure that we are the enabler of that transition. Because by default, if you're not the enabler, that means you must be a barrier. And the one thing we don't want to be is a barrier to the country's ambition.
No.
So I've had a busy 5 years.
I bet you have. Goodness me. So, and what I was going to say right at the beginning was, I've kind of looked at so many things that you've been involved in, and you're so well recognised in the industry, and respected. I just wanted to kind of get you on here because I just thought the kind of person you are, it was really important to me to bring somebody on with your, with kind of your background, and actually, like you said about demystifying things. I think that's kind of what people need, because as I said to you before we started recording, my knowledge of certain areas, especially renewables and things, I'm learning. I think we're all learning. We're all on a learning curve, unless you've been working in the industry as you have for a number of years. But to me, it's about educating people so that they can understand what they can do, little by little, and if we kind of move on to what you as a person, as an individual and as a family, you're very close to where I live. We're kind of both on the outskirts of Reading. We still couldn't get face to face though, but it's just one of those things. But even so, you've decarbonised your own property, haven't you?
Yeah, absolutely. So almost 11 years ago, so it'll be 11 years in April, we bought a derelict house. Okay. It was one of those. Actually, can I tell you the words on the particulars? It says a challenging renovation proposition, which basically tells you there wasn't a lot left. So I bought an old house. So some of the houses you might be able to see has got beams in it. The oldest bit of my house is 600 years old.
My goodness.
And we could barely afford to buy it, let alone renovate it. And we lived in a caravan that we bought on eBay in the garden for the first year.
Oh, did you?
And so we sort of did one too many watching of Grand Designs, and thought we could do that. So anyway, one of my very first conversations was with the electrician, and he said 5 minutes. And I said, what do you mean? He said, well, if I switch it on, it's all going to go up in flames. So phone the fire brigade now, and they'll have a 5-minute head start. So basically, he condemned all the electrics. And then he said, oh, you're going to have fun heating this. And I said, well, what do you mean? He said, well, it's big and drafty and there's no insulation. And at that point, I had thought, how am I going to heat this? So wandered round. There's a fireplace in every room. And I thought, hang on, where am I going to get the wood to keep fireplace? I'm not going to do this. So I literally, at first principles, tried to work out, well, what can I do to make it more energy efficient? I mean, it was missing bits of roof and missing windows. So, I mean, it literally is a building site. I asked an energy expert to do an energy survey. And the conclusion was, and I even remember it to this day, his name was Darren, and he said, I've done the calculation. He says, your property has the same thermal performance as a marquee. And I'm like, okay, what does that mean? He said, you better get another mortgage to heat it. So I said, well, okay, what can I do? And so it was almost at that first principles that he said, you're going to need an industrial size boiler, an oil boiler. You're going to need a transit van size oil tank to keep that going. And it's going to cost you £5,000 or £6,000 a year in oil just to keep it warm.
Oh my goodness.
And at that point, I kind of had a quiet moment with myself and just did that, oh, what have I done?
Yeah.
So very simply, we did an energy survey. We worked out the calculations. We then did how many kilowatt hours of heat will it need to keep this warm? What can we do to insulate it better? Not very much because it's a listed building. And it was then a case of, if it needs this much heat, what does an oil boiler look like? How much oil would we use? What does that look like? And then I went, yeah, but I don't really want a transit van size, tank of oil in my view. And I don't really want the smell of burning oil. So literally necessity said, what are the alternatives? So I just kept asking the daft laddie question. What is my alternative? Found somebody who was just getting their MCS accreditation for installing heat pumps and solar panels. We literally sat down and worked it all out. Because it was a derelict house, we needed everything. And so we put in 28 kilowatts of ground source heat pumps. So I've got 2 heat pumps that run in tandem. They either run separately or together.
Yeah.
That heats all my hot water and all my heating. I've got 2 kilometres of pipe buried in the garden. So we had a digger and we just buried a load of coily pipe in the garden. Then I realised that I was going to use more energy, so I switched to a smart energy tariff. I'm actually with Octopus at the moment. So I set my heat pumps to run only when the grid is cleanest and cheapest. Then I started my job at National Grid, and I had to get an EV because leading transport, you had to have an EV. So I had an EV, and I put in a smart charger. So my car charges when the grid is cleanest and cheapest. And then also with the house, we're not on the mains drains. So I thought, well, why am I just putting it into a tank and getting someone to pump it away and spending a lot of money? So I put a biodigester in. So we actually treat all of our own wastewater on site. So my house is effectively carbon neutral in its operation. So I buy clean electricity, I use the heat pumps, my transport's clean, all my wastewater is clean. But the one thing I can't do, because it's a listed building, is I can't generate my own. So unfortunately, if I could have solar panels, I could use everything, but I have to buy clean energy. But even though I buy clean energy, I do these things I watch how dirty the grid is. So even though it's a clean tariff, and we can pick this up in a little bit, what comes out of the socket isn't clean all the time. So even then, I use my energy when the grid is cleanest and cheapest. So 72% of my consumption happens off peak.
Right.
So it works. It's complicated, but actually it's normal for me now because I'm 11 years into doing this.
That's amazing. So you're saying, so your installer was literally right at the beginning of their kind of actually
correct
installing ground source.
And it's understand. So I was their first ground source installation. So we literally sat down and I said, what are you calculating? And he said, well, I'm looking up numbers from here. I went, okay, but where does that number come from? And we looked it up and they said, well, I've calculated the room area. Can I check it? He said, I'm checking. So literally from first principles, he was sense checking with me his training. Yes. And I'm asking the daft laddie questions. Yeah. And then he's sense checking with me the conclusion. So we literally got to a point which is, are we going to do this? So I was the biggest and first installation that he'd ever done with ground source. And all I can say is I live in a 600-year-old house, which doesn't have high thermal performance, doesn't have loads of insulation in the walls. It doesn't have high-performing double glazing. I mean, I've got wibbly wobbly, greenhouse glass in these windows because it's a heritage building. Yeah. But I'm 11 years warm and dry, which means when people say you can't heat a house with a heat pump, you can.
Because that's kind of what we've been worried about, really, in a way, because it's kind of, you hear all this this noise about what you can and can't do. So you can only, this is why it's good to talk to people like you, because you can only go from that information that you've been given or you've heard or you've read or whatever.
Absolutely. Learn by doing, Liz. I mean, as
Yeah.
someone who looks at continuous improvement, right, the best thing to do is learn by doing. Do
Absolutely.
something, pivot, learn, develop, do a bit more, pivot, learn. I mean, you've lived this. But in the same way, just through the energy transition lens and the climate transition lens, I've learned the same way. Do, learn, do, evolve, right? And you bust your own myths along the way. I mean, let's face it, Liz, I'm a complete petrol head, right? Until I had an EV in 2017, I'd had every kind of turbo nutter, GTI, 16 valve, whatever it is. You know, my friend was a co-driver in a rally team, so I stood in a ditch in the Welsh Forest when he came past 100 miles an hour showering in gravel. My wife used to work for Bernie Ecclestone in Formula One, so we used to go to all the Grand Prix, which was marvellous, right? But I was working in the wind industry, and I just thought, my hobby lifestyle choice doesn't really match my career choice.
Yeah.
So literally, in a fit of desperation, which was, I need to try this, but I'm the last person to drive an electric car. I borrowed a Nissan Leaf, the early Nissan Leaf, and they were doing a 4-day test drive. And again, the 4-day test drive is learn by doing. So I was going training into London every day. And it was costing me, I don't know, £28 a day on a train ticket. I got an electric car for 4 days and commuted into London for less than £2 worth of electricity. So even the train ticket saving would have bought me the car, right?
Yeah.
And after 4 days of just plugging it into a 13-amp socket at home and driving into London, you kind of go, wow, this changes everything. And so that Nissan Leaf, plugging it in, I then changed careers to work for National Grid, decarbonise the house. And so that learning by doing is simply what I do. But it does allow me to talk from a position of knowledge because I'm actually doing this. I'm not telling people they need to do this. I'm doing big government policy, big regulation, right? Looking down. But I'm doing engaged consumer who's doing these things looking up. So I guess the reason why it's good to have these conversations is my knowledge gap is probably narrower than many.
But the amount of knowledge in that, even if it's niche, the amount that you've got in that niche is just phenomenal, isn't it? Really?
Well, I don't know. You see, you think it's phenomenal, but for me, this is every day. I mean, when people don't forget, there's a conversation around normalizing things. So it's incredibly rare for me to go to a petrol station. The dirtiest thing I do is mow the grass. So I go to the local petrol station with a jerry can. Right. And so for me, going to a petrol station just feels really weird because I rarely do it. But plugging a car into charge that's normal. So I think it's one of those things, depending on where you are on this journey, it's either new and fearful, or it's new and exciting, or you've already done it and there was nothing to worry about, or you've been doing it so long, it's normal. So I've kind of, in my mind, heating a building with a heat pump in the garden, treating my own wastewater, driving an electric car is my normal. So it's normalized for me, which means I don't fear it, but that means I'm best placed to, because I've been through the fear of change, acceptance of change, living through the uncertainty, right? Exactly. And so, again, thinking about your continuous change, your continuous improvement piece, I've gone through that pit of despair. I've gone across the chasm. So just to some extent, you're very, very kind and very flattering, and it's a little embarrassing really, because for me, this is just my normal, right? Yeah. And it links me to a thought I had. Often I'm challenged, and you and I had this conversation previously. Yeah. When we're thinking about the change to 2050 and clean air and clean power and what have you, often people level at me like, oh, it's going to be really difficult, and it's going to be really, we're going to be living in caves, wearing loincloths and chewing grass. and I often reflect on
what we do here.
Maybe. but I was reflecting on that normalization. So everybody listening to this podcast, if they're in the UK, has saved the UK about 10% of our peak demand every night of the week.
Yes.
And often when you talk to people, you kind of go, well, thank you for doing that. And they look at you blankly and go, what do I do? Well, whilst you and I are having this conversation, the people listening are going, hang on, what did I do?
Yeah.
Well, if you think back, I think it was about 12 or 14 years ago, Europe banned the sale of the incandescent light bulb. Right? And so those very early compact fluorescent light bulbs, you'd switch them on and they were a bit dim and they'd get a little bit bright. Right. But now we all have high performing LEDs. I mean, I've got one on my desk now. You've got one where you are.
Yeah.
So we're in a position where we've normalized very smart, energy efficient light bulbs. We don't go into wherever you buy, you don't go into B&Q and say, hello, B&Q operative. Can I have a climate appropriate, energy efficient, COP26 approved smart energy light bulb? You say, can I have a bayonet fitting or a screw fitting? I mean, but we've normalized it in the same way. Today, somebody will come to you and they'll say, oh, I've just ordered myself an electric car. And nobody says, well, what make or colour or what seats did you? No, it's an electric car. And I know you're going through this yourself, Liz.
Yeah.
But if you think about it, we will know that we've normalised electric transport when somebody comes in and says, I've bought a green Volkswagen. And you won't ask what's under the bonnet. You'll say, oh, did you get the cream seats or the black seats? Or the, do you know what I mean? And I think we could be 6 or 7 years away from that, and we will have normalised electric transport. So I think some of this thing is part of the transition. Is some people fear change because change is always interesting.
Exactly.
But the minute you start to normalise this sort of goes a little easier. I mean, did you? Again, it's the smile. I'm smiling because it makes me think about my kids. Right. I remember before mobile phones, where the only choice was with a wire.
Yeah.
And then we had the early mobile phones, which only made a phone call, right?
Yeah.
Oh, the big old brick things, right?
Yeah, the brick ones.
And, those will never catch on. And now we have on an iPhone, a film studio, a camera, a web browser, everything on an iPhone. But you didn't wake up one morning and go, I need a smartphone.
No.
It's been an evolution and we've now normalized it. Everybody has one. Some people have two. And so I think when we think about the challenge of the energy transition, a lot of this will, in time, just become normal.
And talking about going back to the grid, then going back to National Grid.
Yes.
Because you've been on so many different podcasts, and I was listening to you on with Robert Llewellyn. I know you're good friends with him, aren't you? On the Fully Charged podcast, and you were talking about how no matter who you buy from, what you get, you kind of intimated this earlier, what you actually get in your socket is dirty. But you also said to me last week, we had, 87% of the UK was running on renewable energy last week. So can you explain the dirty bit?
Yes.
And how we managed to, how do people not realise that we are running on such a high amount of renewable energy when people, like I said to you, when people are kind of saying, we're a long way away from all this.
So let's do some big things. So let's just ground this to start with. So since the start of the Industrial Revolution until about 2017, the dirtiest thing we did as a country was make power. Principally coal. Then there was the dash for gas in the 70s and 80s. Some nuclear in the 70s. Right. So what's happened from about 2017 onwards is, from 2017 onwards, making power stopped being the dirtiest thing we do, and transport became the dirtiest thing we do. Now, that's not because transport suddenly got dirty. It's because for 20 years we've been making the power system cleaner. Okay.
Yes.
So often when people think about the change we're on, they think about us starting now. Or electric cars, we need to think about cleaning the power system. The power system has been under an evolution for about 20 years. We now as a country averaged out across the year, consume more power from clean sources than by burning stuff. Okay.
Right.
Now, that doesn't, as anybody will tell you, and some of these armchair experts will go, yeah, the wind doesn't always blow like it's a shock. And then they'll go,
Yeah.
oh, the sun doesn't always shine.
No
So
way.
let me explain where the power comes from as a real mix, right? So there is no one magic bullet to run a country. Okay, some countries get close to it, but every generating technology has its shortcomings. So, if you burn coal, you've got to dig it out the ground and you burn it and you've got the emissions. If you do gas, you've got to dig it out the ground and you've got the emissions. If you do nuclear, you've got the long-term waste and the upfront cost of the power station. Wind farms work when it's windy, they work less when it's not. Right, so there's no magic bullet for running the country. So what we have is a real mix. So nuclear is generally on or off. It's very difficult to turn it up or down. It's generally on or off. But energy demand goes up and down, up in the morning for breakfast, and then drops off at lunchtime, and then peaks in the evening, and then almost collapses overnight, right? So we've had an energy system that's been trying to be built for the most demand on the most extreme day, which means we've got a very robust, reliable energy system, one of the most reliable in the world. But it's built to that peak demand plus a little bit of headroom.
Okay.
But hang on, we've got nuclear that just runs all the time. That's base load. We've got renewables that then run. And then the bit that balances, the real-time supply and demand between demands and that supply, the most flexible plant at the moment is gas. So gas is often, at peak times, the biggest generator of power. It's why we're suffering the cost of energy right now, because gas is the plant that runs, that keeps the lights on. It's that last bit of balancing cost. So we've got this mix of generation. We've got, and it's getting cleaner all the time. It's taken us 20 years to get to 10 gigawatts of offshore wind, and we're going to get to 40 by about 2030, right? That's huge. In the UK's British energy security strategy, there was talk of more nuclear power stations, more solar, more interconnectors. So the UK is going to be a net exporter of power. Yeah, we'll make more than we need, so we can sell it to other countries across interconnectors, wires in the sea. But also, what that tells you is, even if you buy your power from a clean, right, it's a clean tariff, what comes out the socket isn't clean. And the best way I've had to describe this is, imagine the UK's power system is a bathtub.
Yeah.
Okay. So in your mind, think of a clear bathtub.
Yeah.
Now the bathtub has to always remain half full.
Yeah.
That's your 50 hertz. That's the frequency at which the energy system runs. So we have to keep it half full, 50 hertz. Think of lots of taps around the edge of the bath. So one is coal power, one is gas power, one is nuclear power, one is wind power, one is solar. So when a wind farm makes electricity and puts its electrons in the bath, it has a certificate which it gives to, it goes with the power. It goes to your energy retailer that says you put 1 unit of electricity in the bathtub. You, Liz, and so of course, when you think of the bath is a mixture of all of these colours of energy, right? So it's brown.
Yeah.
So when you, Liz, as a buyer of clean electricity, what comes out of the plug hole and arrives in your electrical socket is brown. But what happens is, your retailer, when you use that 1 unit of green electricity, they surrender the certificate. So they know that 1 unit of green electricity went in the bath, and you used 1 unit of green electricity. That's how your power is clean, right?
Okay.
Which is why, even though I'm on a clean tariff, I still choose. I have the carbon intensity app. It's a free app. It tells you how dirty the grid is. National Grid provide the data to tell you how dirty the grid is in real time and with a 2-day forecast. So even though I'm on a clean tariff, I still avoid using energy at peak time, because the grid is the dirtiest. Okay?
Of course, makes sense.
But what's happening now is, the clean providers of energy, because they know people can have a digital nudge to use more when it's plentiful, and a digital nudge to pause when there's not as much, what it's doing is it's driving the energy retailers to buy more and more renewables. Okay. And so actually, the power system in the UK is destined to be run clean, so no burning anything, right, in 2025. That's 2 years from now, right? Now, admittedly, so the very, very clever people at National Grid ESO, the electricity system operator, the control room, the secret one that's just over there. There's a big Google. Liz, if you look on Google, there's a huge push pin and it says National Grid. So it used to be secret. It's not that secret anymore. But what they've done is they ask power. So let's just again piece two things together. So demand just goes up when people use stuff and then goes down again across the middle of the day and up in the evening and then low overnight. So historically, the power system has had to generate more to meet that demand, and then generate less to meet that demand, and then generate more. So you're turning power stations up and down and up and down and up and down all day long to balance the grid. The ESO control room do that. And so what we're now, in the way we're moving forward, is they've had to get even cleverer, because instead of having a handful of big thermal power stations, there are now hundreds and hundreds and hundreds and hundreds of wind farms and solar farms and you name it, battery storage and all this sort of bits and pieces. So they're getting very, very smart at managing much more finely that real-time supply and demand. And so the control room, the National Grid control room, is set to run the country clean in 2025. So just 2 years from now. Now, admittedly, it'll be 5 minutes. And then they'll stretch it out and manage, and it'll be 10 minutes. And then they'll learn a bit more, and it'll be an hour. Then it'll be a day, and then it'll be a week, and then so the UK's power system has to be clean by 2035, and we will be able to run the system clean by 2025. Admittedly, in 2025, it's little bits of time, and they'll be learning and refining and learning and refining. But the other side of that, Liz, is up until now, the power system has to turn up and down to match real-time demand. But something funny's happening. People are having EVs and heat pumps and time-of-use tariffs. So what you're starting to see is, instead of turning power station up, you can turn consumption down.
Oh my God.
Right, so now we've got twice as much flexibility as we had. And so I think Octopus Energy, in the last demand turn down, they turned down, so enough customers with a signal are rewarded for this, turned down their usual consumption, and it avoided a power station being fired up.
We did that.
So you did that. So in which case, do you know what you've done, Liz? You're a pioneer by doing that. Do you know what you've done is you've democratized energy. Right? So you and I know, right, through most of our lifetime, we've had energy done to us, right? You know, you read your meter, you submit your number, you get a page of numbers you don't really understand, and then you have to pay a bill, right?
Exactly.
Right. So you know, when you ask most people, say, how much are you paying a kilowatt hour? A what? You know, my bill's this much a month or this much a quarter, right? So what we're moving into is with smart meters and smart tariffs, people are now able to actually play a part in the energy system. So, for example, I mean, I know you've been exploring this. You can make it yourself. You can put solar on the roof. So you can make your own power. And the power that you don't use, you can get paid for when it leaves your house. Fantastic. And then you see people having an electric car, and their bill goes up. Yes, but they're not paying it on petrol and diesel anymore, but the home electricity bill goes up. So the next thing they do is they say, well, can I have a smart tariff? And then they put a timer on, or a smart charger, and so it charges when the grid is cleanest and cheapest. Hang on, you've just become a participant in the energy system. So if you then take that further and have energy storage, time of use tariffs, a heat pump and a water tank, what you've actually done is democratized energy. If you want to, you can become a participant. Now, you can either be really geeky and turn stuff on and off. I don't have time for that. Well, no, actually, to be fair, I don't have time to be geeky, so I outsource most of this to apps. So National Grid publishes an API signal, which is how dirty is the grid.
Right.
My energy provider provides an API signal on the cost of energy, and there's a little algorithm in the background says, is it expensive and dirty? Don't do it. Is it clean and cheap? Do it. So
Oh, that'd be me
literally,
then. Yeah, that'd be me. I'll be
right.
going for
So
the app, definitely.
well, exactly. So what you find, Liz, is actually even if you're not geeky, you can outsource the smartness. You can outsource the smartness to an app, right? And it'll just tell you how good you've been. So to some extent, this change that we're on is a change in how we make power, how we run an energy system, how people consume and participate in the energy system.
Yeah.
So
Yeah.
it really is genuinely democratizing energy. And if you follow this to its end destination, theoretically, at some stage in the future, if you were making, say you've got solar on the roof and you're making more than you consume, instead of it just spilling into the energy market, which is what it does today, you could theoretically sell it to your neighbour next door, peer-to-peer trading. Who knows? I mean, this could go anywhere. But this is where, this is not, we know how to make clean power, right? We know how to do clean transport. Actually, the innovation here is business model innovation. It's not technological innovation to too much of an extent.
This is brilliant. Honestly, I've not even, I'm just thinking about Linda next door. Can I have a chat with her now?
Well, I'm going to say, yeah, you could be trading. You could barter. You let me have your electrons from the roof. I'll let you have a loaf of bread when I've used the oven with your electrons to bake a loaf. Who knows?
It was so interesting at first. So yeah, we've been with Octopus a little while, and at first, my husband, obviously because of what my husband does, he was kind of straight on it. You know, right, okay, we're going to make sure that we kind of turn everything off as much as we possibly can, and we've got a smart meter so we could see what the usage was. I mean, the worst one was my 17-year-old son on his Xbox. We couldn't actually, kind of prise him away from his Xbox for an hour, but actually we could monitor it. And I wrote a blog actually called "Sat in the Dark with the Lights Off." We did actually had one little light. And we made sure we just for the trial, and we think we've done four of the trials now.
Yes.
And the trial, me and my husband sat in one room with a tiny light on, and we checked to see how much energy we were actually consuming because of it. And yeah, fair enough. I think our saving was something like £2.30 or something like that. But actually, if you look at how much everybody who was doing that trial was saving, and like you said, kind of. It saved enough to turn off a power station for a specific length of time.
But also, let's piece a few of these things together, Liz. So, at the outset, I was saying, look, by 2050, the UK will consume at least twice the amount of electricity, need 4 times the amount of clean generation, twice the grid.
Yes.
That's the best solution, right? That assumes smart consumption, demand-side management, what you're doing. Yeah. It assumes distributed energy, so you can generate what you can. It assumes smart grid optimization. It assumes really good forecasting of generation. So actually, what you're learning to do now with that demand side management might be a little bit geeky and a little bit fun, and it's a novel. But think about in a world where you have heat pumps and you have an EV and consumption's going up. Actually, if we don't do this smart demand side management, the UK will consume more than twice the amount of electricity. Yeah. It will mean we need more than 4 times the amount of clean generation. Yeah. It will mean we need more than twice the grid capacity. So actually, as a pioneer in learning by doing at the early stage, this is how the energy system will evolve in the most economic and efficient way to get us the best outcome for the least cost.
And obviously over the last few months they've been talking about the fact that we might run out of energy. I mean, obviously a lot of the stuff that comes through the media, some of it, it's
there to sell papers, or it's there to get eyes on your screens. Yep,
it's scaremongering, isn't it? And I really don't agree with that. So I try and turn a bit of a deaf ear, to it.
I don't know. I mean, the thing is always ask and challenge, right?
Yeah.
So let me just give you some context for some of those negative press. So every year, the clever people at Wokingham Control Room, the central control room,
know them well.
So they're really, really good at forecasting. So under legislation, National Grid needs to do a summer outlook and a winter outlook. Now, the summer outlook is how little is the country going to need in the middle of the summer? Yeah.
Right.
And the winter outlook is what is the most that we're going to need in the winter. And that winter outlook is based on a whole bunch of stuff. So, maybe a nuclear power station says, well, we're doing a bit of a refit, so we're going to be off for 6 months. Maybe they're reconfiguring or building a new power station. So all of the generators say, what are they going to do? So what National Grid does, these clever folks in the control room, is they look at previous winters. Is it a cold winter? Is it a warm winter? What's the forecast saying? What generation is available? Do we have any big sporting events? World Cup, for example.
Exactly.
All of those bits and pieces, and they stir all that into their analysis. And so every year, without fail, they do a summer outlook and a winter outlook.
Okay.
Now, this winter, they did that as normal. And they said, we've looked at what power can be made, and we've looked at the availability, and we've looked at the long-term weather forecast, and it will be fine. With a nice little margin, fine. And then government went, will it really be fine? So National Grid said, well, we can rerun the numbers with some more worst case scenarios in. So they went, yeah, do that. So National Grid, as a reasonable, prudent business, reran the modelling and said, well, what if there wasn't enough gas, right? Well, bearing in mind, we're not very reliant on, we don't get any of our gas from Russia.
No.
A little bit maybe. But we are impacted by the price. So they then reran the model and said, okay, so normal model says we'll probably be fine. Bit more extreme model says, okay, well, we could get close, because we operate the system with headroom, spare, right?
Okay.
So they then reran the model and said, what if there's a real scarcity of gas? What happens is, not that there won't be enough, but the headroom, the spare capacity, the margin, we call it, starts to get a little slimmer. So anyway, then there was that discussion, which is, hang on, what if we had a real set-to with everybody in Europe? And the wires between the UK and France and the UK and Germany and the UK and Norway, and right, what if they wouldn't allow power to go backwards and forwards? So what is like the worst case? So there's a problem with gas and you couldn't flow power backwards and forwards. So under the worst case scenario, in the report, they went, it's very unlikely, but there might be a small chance of having to ask people to switch stuff off. And of course, the newspapers pick up on that line, which was the most extreme. But as we know, and again, it's got to be a grown-up conversation, you can never say never. But what it did is it drove quite a lot of hysteria on the lights are going to go out, right? So what I'd say is, when you see those newsworthy, right, pieces, don't accept what the reporter's saying. They will reference the document. Read the executive summary of the document they're reporting, because actually what that winter outlook said is, under pretty much every scenario we can think about, it'll be fine. But if you really wanted to go extreme, it might get a little bit tight. Okay, but it's the tight bit that they picked up on. But even then, and again, this is one of those things that when you see everything that's happening in the marketplace, what it actually did is, to prepare for that most of extreme, it drove the testing of that demand turn down as a trial, right? So we've learned something out of this crisis
already.
But also, even National Grid's control room contracted with some of the older. Even though we only have really one operational coal-fired power station these days, there are 2 or 3 which are mothballed. So they're still there. They still have a pile of coal outside, but they're not warmed up. So even then, if there was the crisis, National Grid did 2 things. It contracted with some of the coal plants to say, look, if it looked really dicey, could we pay you to chuck some coal on and fire up as an insurance policy? So that was there. And then there was this demand turn down. Again, could we ask people to voluntarily use a little bit less and reward them accordingly? What it's actually done is it's shown that the energy system is actually incredibly resilient, even in a global energy crisis. The lights stayed on, commerce still kept running, right? And yes, we are all still hurting off the cost of electricity. But most of that is driven by gas, which is a global commodity.
And just following on from what you just said there about kind of mothballing coal mines, and probably know where I'm going to go with this one. Obviously, there's kind of been an agreement for an additional coal mine, hasn't there? But
Cumbria, yes.
Yeah, if we've got mothballed coal mines that could necessarily provide us with what we needed in that situation, why do we need another one?
No, so sorry if you misunderstood me. Coal-fired power stations, not coal
Ah,
mines.
sorry. Yes.
No, that's
Right.
fine. No, that's fine. No, but that's why it's good to have a conversation, right?
Yeah.
Clarify, explore, understand. So my understanding from the Cumbria coal mine is that's not for burning in a power station. That's for helping to make steel. Yeah, it's coking
Okay.
coal for the purposes of making steel, which was part of the justification for it, because in the UK by 2025 there will be no more operational coal-fired power stations.
Right.
So the part of the justification in Cumbria is for making steel.
Okay.
So it's
Again,
not for
like I
burning.
say, you hear again. It's the information that's out there, and you sometimes listening to the wrong people. Obviously, I'm listening to the right person now, which is
Oh
good.
well, maybe, but I mean, I'm sure there'll be listeners going, "Oh, he's wrong." That's fine. It's healthy to disagree. I mean,
Yes.
it's sort of what we've lost with the internet, really. With social media, somebody has to prove you're wrong so that they can prove they're
Oh,
right. Actually, what we've lost is open dialogue, challenging what people know, and that's why these podcasts and these things are really useful to do. But
yeah.
at a personal level, I mean, professionally, it has no impact on National Grid. Personally, I'm a bit uncomfortable about opening a coal mine.
I
Um,
know. That's
at the
what I mean.
moment, the steel industry is trying to actually clean up its act, right, and
Mm,
find
mm,
electric arc for melting and smelting,
yes.
steel.
Yeah.
They're looking at hydrogen for some of these high energy demand things. It feels to me that it's a bit like, why are we rolling out Victorian infrastructure for something
Exactly.
that's 21st century? I
Mm.
don't know. I mean, it'll be interesting to see, one, from my perspective, does it ever actually get built?
Watch
Is the
this space.
demand there for it? I guess all we
Mm.
can see is watch this space. But personally, it makes me feel a little bit uncomfortable because the best place for coal is leave it in the ground. In the
Yeah.
same way, the best place for oil is leave it in the ground. We're still going to need it for plastics and synthetics.
Yes.
Burning it feels a bit idiocy to me.
So just to finish off with, so you are going to be leaving this country in July, aren't you,
I
to
am,
work
yes. Yep.
for Jacobs, and we're not talking about the cream cracker company, as my husband was asking earlier as a bit of a joke. You are Vice President Global Solutions,
Yes.
looking specifically at the energy transition for the
Yes.
USA, because as you were saying to me before we started recording, that the US are in a slightly different place to where we are currently. So
Yep.
so just to kind of finish off with, what are your aims for what what you want to achieve when you move over there?
Yeah, no,
And
certainly.
actually,
Okay.
do you know what? My other question would be, when you go out there, obviously you're going to, find the right place and settle down where you're going to live. Are you going to look at either buying a pre-decarbonised house, or will that be something that you want to achieve while you're over there?
Yeah, so let's pick that up. So yes, if you think about the US, they're only just getting into offshore wind. In the UK, we've been doing offshore wind for 20 years. I spent 11 years developing an offshore wind farm, right? So to some extent, I'm an exportable commodity.
You are.
If you look at the United States, somewhere like California, huge penetration of EVs. There's nothing that I can help them with there. They're well on that journey. But if you think about it, it's as far from where you and I live to the east coast of the US as it is from the east coast to the west coast of the US.
Yeah.
It's a big place, right?
Yeah.
But when we look at the energy transition, and the reason for my role is, it's joining the dots, right? So I mean, for example, in the US, Jacobs are doing a lot around helping improve public transport for clean air. But you need to match the clean energy and the smart consumption to the transport. So I'm trying to bring some of the energy component to some of those challenges. It's also joining the dots, right? Because not only are you trying to do things cleaner, you need to build in resilience to extreme weather events, because we're going to get more extreme weather events. So again,
Yes.
Jacobs does a lot of stuff in people and place and big engineering, big project management projects and those sort of things. So I'm taking some of what we've learnt in the UK and Europe and taking it there. But at the same time, some of that is interpreting it. No two countries are the same. No two power systems are the two same. No two markets are the same. So I've got a lot to learn when I go. The exciting thing for me is I can rent out my house here, so someone can live in, an effectively carbon neutral house.
Yes.
My biggest worry when I get to the US is I'm desperate to get into an electric car, but initially I'm going to rent somewhere, and I don't know whether they'll let me have an EV charger in the driveway or not. So I don't want a gas guzzler. I really want an electric car. But ultimately, I'm going out there for 2 or 3 years. I may want to stay. I may want to come back. If I decide to stay, then I'll want to do something clean and high tech and try and take some of my learning. Or if not, I shall help the US and help Jacobs and help some of the big transition stuff. And then I'll come back and take some of my learning and bring it back here again. I mean, often people forget, Liz, and I guess as a final point, is this is not a cliff edge.
No.
This is a transition, right?
Yes.
Do the stuff that's doable now. It buys you time to do the stuff that we don't know how to fix yet. Yes, time is urgent. We need to do as much as we can as soon as we can. But I think as particularly someone who looks at continuous improvement is do something. Don't wait for the perfect. Do something that's better than today and then learn a bit more and do. Yes, it's continual improvement. In the same way as we spoke about before, we've normalized LED bulbs. Right?
Yes.
In the same way, in the next 5 or 6 years, we'll normalize electric cars. And then in the next 7 to 10 years, we will normalize heat pumps. And then we'll be like, what were we ever worried about? But people fear change, but you just have to make a start. And so I would strongly urge anybody to challenge the myth, bust your own myths, learn by doing, talk to people. No one knows. If somebody tells you they knows what the answer is to the energy transition, they're probably lying because no one knows all the answers. We've just got to learn by doing. But ask, challenge, try, do. This is a transition, not a cliff edge.
Absolutely. Graeme, it's been an absolute joy talking to you. I really, really appreciate your time, especially, like I say, you're kind of moving into a new role, and it just sounds really, really exciting. So I just want to say thank you ever so much for joining me. I really, really appreciate it.
Thank you, Liz. It's lovely to spend some time with you.
And for everybody else, I'm going to say goodbye, and I shall see you all next time. Thank you. Bye. Bye. You've been watching Electric Evolution with Liz Allan. Don't forget to subscribe and click on the bell icon, and you'll receive all of our weekly videos. Thanks for watching. See you soon. Bye.